Alright, so this video will focus on Chapter 5, Section 6. And as we look here, it says here to first of all plot these different points on a coordinate plane and then describe the location of the point. So I want you to quickly pause the video, graph these out, and then press pause or play. Alright, so now that you've had a chance to go through and actually solve these or graph them out, it should look something like this. And if you look at them, there's a lot of these lines here that are really close. And if I start moving at the origin and you move 4 units left and 2 units down and plot a point. So check this out. If I go down 1, 2, and then 1, 2, 3, 4. That's how I get to A. For B, I go down 1 and I go over 1, 2. C is right on the origin. D is up 1 over 2. E is up 2 over 4. And then F is up 3 and over 6. And if I draw a line here, let's just see what happens. If I go from here to here, you're going to notice that's a straight line, and it goes right through the center of the origin. This here is called direct variation, and it's something we're going to be focusing on this section specifically. So it says, how can you use a graph to show a relationship between two quantities that vary directly? And how can you use an equation? So as we go through here, we're going to look at these different ordered pairs. And I want you to think, do these do the same thing that we saw before? Or are they actually directly or very directly? So if I look here, let's just quickly draw these points out or write these points out. I'm going to have 0, 0, 1, 6, 2, 12, and 3, 18. Now again, the important thing is it goes to the point of origin. That's the first thing. So it has to go through 0, 0. So that meets that criteria right there. Now it's going to go by the same amount every time. This is 6, this is 6, this is 6. That's good. This over here is 1, 1, 1. So my slope, my m, equals 6 over 1. And my equation would be y equals 6 over 1 m plus 0, because my starting point is at 0, 0. Therefore, this is direct variation. This one here, we're going to do the same thing we just did a moment ago, where I'm going to plot these points out. So I'll say -3 and 6, 4 and 8, -5 and 10, and 6 and 12. I can already tell that this will not work, and I'll tell you why. I go here, it's 2, this is 2, this is 2, so that looks good. I don't know about my starting point, I don't know where 0 is, but look at this. This is 7. This is going down by -9. This here is going up by 11. So these are all different, right? So it is not direct variation. And then finally, the last one is I'm going to draw these points out, and I'll have my 4, 6, 8, 12, 12, 18, 18, 27. If I look here, these all go up by 6 every time. So this is good so far. Well, these two. This one here, this goes up by 9, right? So not quite there, but let's keep looking. This here is going by 4. This is going by 4. This here is going up by 6. So far my slope is 6 over 4 or 9 over 6. And let's just see if these are the same. So I can take a 2 out of both of these and I have 3 halves. And I can take a 3 out of both of these and I have 3 halves. So even though they look different, they are the same slope. But the problem is I don't know what my starting point is. So let's subtract by 4, so I get 0. And subtract by 6, and I get 0. So it meets both ends of the criteria. I have my equation, which is y equals 3 over 2x plus my starting point of 0. So it is direct variation. So here's what direct variation is. It's constant proportionality, and it goes through the point of origin, as I keep saying. So make sure that it meets those two criteria. Number one, that it goes up by the same amount every time. It has the slope is the same. Even if it looks different, when I reduce it down, I'll get the same slope. Or the second criteria, or I should say, and the second criteria, is that it goes through the point 0, 0. So let's look at these here. if I look at this, I want to see if they're going up by the same amount. This is going up by 2, 2, 2, 1, 1, 1. That's perfect so far. If I would then go for my 0, because I want to get my starting point, well, it's got to go down by 2 more, right? So it'd be -4. And 0, -4 does not go through the point of origin. So although it is linear, meaning it has the same slope, it is not direct variation because it does not go through the origin. So it should go through here if it was direct variation. So it is not direct variation. This one here goes up by 2, 4, so it's 2 every time, 2 over time. So this is y equals 2 over 2, or y equals 1 x plus 0. So it is direct variation. This one here, if I want to get I have y plus 1 equals 2x, and I want to get the y by itself, right? So I have to subtract 1. Subtract 1. I can't combine these together because this is an x term and this is a number, so I have y equals 2x minus 1. Well, the slope part is perfect, but this starting point of -1 is not direct variation, so this is a no. This one here, I go through, I have 1/2 y equals x. And to get the y by itself, I have to multiply both sides by 2 over 1. So I'll have y equals 2 over 1x plus 0. So this is linear, and it starts at the point 0, 0, so it is direct variation. So now tell whether this shows direct variation. If I go here, I'm already going to say no, it does not, because it's not going to have 0, 0, and that's what I need. This one here, it's going up by 4 every time, so if I went to point 0 here, I'd have to subtract 4 and get 0, 0. This will be direct variation. This one here has 0, 0, looks perfect. It's going up by 2 every time. On this side, it's going up by 1 every time, so this is direct variation. This here, I'd have to divide by, or I'd subtract, let me just draw this out real fast. So I have xy equals 3. And so I'd have to divide by, this is like x over 1. I would have to multiply this by 1 over x, and multiply this by 1 over x. And I would get y equals 3 over 1x plus 0. So that would work. This here would be y equals 3x. That would be. And this one here, I'd have to subtract the 1, and it would not start at 0, 0. So I would say no, yes, 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 no. So no, yes. Oh, I made an error. So this right here, although the slope is 2, I didn't do it properly. Let's look at this here for a second. And this is okay. I'm going to keep this in the video because it's important to make this distinction. So if I have -2, -1, 0, and 1, and this is 4, 2, 0, 2. This difference is -2. This difference here is -2. This difference here is +2. So although it's the same absolute value, it's a different direction, therefore it is not linear. So let's look at this data and see if it's proportional. So this is going by halves every time, right? So 1/2, and it goes, let me just write this down. So I'm going to have 1/2, 1, 3/2, 2, and then the other side, I want to have, of course, 0. And then I'll have 8, 16, 24, 32. It appears that these are all going up by 8. So if I want to go to 0, I have to go down by 8, right? And that equals 0. It appears that these are all going by 1/2. So to go down by 1/2 is 0. So I would say this is directly proportional. And I'd say that the formula here so it would be 8 over 1/2, which is kind of weird to look at. So I just make it 16 over 1. So I'd say y equals 16 over 1x plus 0. Use the equation to find the area cleaned in 10 minutes. So I put down 10 times 16 is 160. There you go. And one last one. So it says the battery weakens and the robot begins cleaning less and less area each minute. Do the x and y show direct variation? Well, no, there's not a constant rate of change. So that is